Hi students, this is Satish Kumar. In this video lecture, we are going to present the properties of work done. In the last lecture, we have seen the expression for work done by an external source. Okay, so here we'll first try to see what is the expression that we have got for the work done by an external source. So we have denoted the work done by W, capital W, which is equal to minus QT line integral. I have denoted the initial or lower limit by B and upper limit with A and E dot dl. E dot dl. This is what is the expression for work done, and I have denoted the units of work done is with joules. Their QT is a test charge, E is electric field intensity, which is created by the charge Q, and dl is the distance moved by the charge, moved by the test charge. Here, the test charge after moving the external source from B to A is obviously here. Now the point is, what are the properties of work done? There are five very important properties of work done that we have to discuss here. First property of work done is, I'll first give you the statement. I'll try to explain. If the amount of or total amount of if the total amount of work done obtained is positive is positive, then work is done by external source. Work is done by external source. Here, everybody will have a tendency that suppose if you look at the expression work done, which is actually by an external source, if you look at, you will always get confused with this negative symbol. Here, because negative symbol, we can think that the work done is a negative, then work is done by the external source. But here the statement is saying that if the total amount of work done obtained is positive, then the work is done by the external source. What is this actually? Here, this is an expression. I'll give you one small example. X is equal to minus Y. Can you say X is negative? Absolutely not. You will always say that based on the Y value, you can able to say the X whether is positive or negative. So the same thing here, just by looking at this work done is equal to minus of something, you cannot say the work done is negative for the external source. Here I'm talking about the total amount of work done obtained. That means after simplifying this E dot dl, which is most of the times you will get positive, and differentiating that with respect to the limits b to a, and after multiplying this with minus qt, if you get the total amount, total value is, let's say, some positive, let's say like w is equal to plus 150 joules. Whenever you get this plus something, some integer value, you will always say that that work is done by the external source. So whenever external source is doing the work, you will always get that work done is a positive value. This is the first point that everybody should remember. Okay, let us take for example with in this particular diagram, right? So first thing what you have to understand is, this is, let's say, a point where the charge is kept and the field is created here. This is this circle which is indicating the electric field, but which is not confined only in that circle, it will be extended up to infinite. Okay, that means it will go like this. It is not confined only in that circle. Okay, it will go up to infinite. Now my point is, from this point, from this center of the sphere, the point A is having some distance. Let's say that area, because it's a sphere, it is simply r. But what is the distance of B from the same point, which is obviously more distance than the distance from the center to the point A. Let us call this is RA and this is RB. RB, obviously it's very clear that RB is greater than RA. Okay, this is very clear. Now the point is, whenever the external source is doing the work, this is the place where external sources start moving it. That means he has to move in this direction, that is against the electric field. So this is now the initial point and this is the final position or final point. Now the point is, whenever you have considered this E dot dl, which is positive, when you apply the higher limit, which is a, because whenever you find out integration, you will always first substitute the upper limit minus the lower limit. So in this E dot dl, if you substitute this a, which is actually the distance RA, which is smaller, this is a smaller value. So this is E dot dl, if you substitute smaller value, minus E dot dl B point if you substitute, but the B is a larger value. That means anything which is smaller minus larger will always give a negative number. That negative into minus q here will become positive. So that's how the total work done W will always be getting as a positive value. That means we can say, because this positive value you are getting when you take the charge qt will be moved from B to A. In this B to A direction, actually the work is done by the external source. Okay, that's about the first point. Then moving to the second point, if the total work done obtained, if the total work done obtained is negative, then the work is done by, electric field. The work is done by the electric field. Now make a look. That means work done here we are getting overall is negative. Then we can say the work is done by the electric field. Let us also make a look at what is happening in this diagram. When electric field is doing the work, electric field actually is in this direction, that is from the point towards the radial direction. So whenever electric field is considered, this is not final and this is not initial. Now here this is your initial position when electric field is moving, electric field is moving the charge, and this is now the final. Okay, so here the initial value is at A, that means RA, which is smaller now, So that is always, RA is always smaller, obviously, and which is RB, which is greater. Now the initial position is A and final position is B when electric field is moving the test charge QT. Now let's make a look at E dot dl. In this particular expression of work done, E dot dl I said will be always positive because we have to consider that is either positive or negative. Okay, so if I consider it as positive value, then what we'll be having is when you apply the upper limit, which is A. So now the final value will be at B, so the limits here will be going to change. Okay, that means initial value is A, so that means this will become A now and this will become B now. Right? So what is happening here is first you will apply B, which is a larger value. So that means E dot dl you have to apply B first. That means larger, minus next you have to apply A, which is smaller. So larger minus smaller will always give you a positive value. That means this entire integration value will be positive, which is multiplied by minus q. You will always get a negative value. That's what is this. That means when the work done is negative, then the work is done by the electric field. That's by looking at any problem. That means when in a problem, the work is done by a particular one is, let's say, some minus 100 joules, then who has done the work? So we no need to have any other information, because work done finally obtained is negative. Here we can simply just say that the work is done by the electric field. That means when the overall work is positive, that work is done by the external source, and when the overall work is negative, then the work is done by the external field. So this is what we should understand. And third and most important point here is, when you, I'll first give you the statement, then I'll explain. The work done is independent of path selected, or we can say the work done in all the directions from the charge q to the from the test charge qt to the position q will always be same. Okay, let us try to understand that. Okay, I'll be erasing all this. Right now, what I'll be saying is, suppose this is qt, and I have to bring that to this position. Right now, I am moving a charge, test charge, in this direction. This is your first path. In this direction, let us call this is first path. And instead of going in a straight line path, I'll be, let's say, moving the test charge in this curve path. Right, this is our second path. And instead of going in this way, I'll be coming like this and will be reaching to the same location. Like this, I can take a number of paths. I'll be going like this and coming to this path. Okay, let's say this is our fourth path. This is third. So in which path I have done more amount of work? Okay, generally the people will think that as we have traveled more amount of distance in this fourth path, we think that the work done is more in this. And the first path is a very straight path and work done will be less. But it is not so in this particular case. The work done in all the cases will be same. Whether you move the test charge from QT to this position, let us call this is B and this is A. Okay, so the work done in this direction, in this path, third path, and fourth path, in all the paths, the work done will be same. The work done will be same. This is because the starting point here is B and the ending point is A. In this expression, if you look at from minus B to A, independent of whether the path length is lesser or more, because you are moving from the same point B to A, so the work done will be absolutely same in all four paths. But there is a condition to have this. Okay, here the condition must be this entire electric field must be conservative field. If this field is conservative, then only this particular condition will be valid. Okay, here we should write that the condition is the field must be conservative. Conservative always means the curl of E is equal to 0. That means the vector E must be irrotational. When when any vector is irrotational and the field created by it is called as conservative, or that is also called a lamellar field. Right? So if this condition satisfies, that means the field is conservative, then only the work done will be independent of the path selected. That means the work done will be same in all the four paths. This is your third point. And the fourth point is the work done in a closed contour. Contour means loop. Closed loop is 0. Let us try to understand what is the meaning of that. The work done in a closed loop. Okay, where is that closed loop? Let us try to understand from this. Okay, I'll be erasing all this now. Okay, so I'll have to start from this point B. Okay, the test charge has to be moved from B and it has to reach A. But what has happened here is you have started from this point B and you try to reach A, but instead of stopping at that A, you have again came back to the same location. That means you are moving from B and coming back to the same position. That means your initial value and final value will be same. Here this B and this A and this B both are same. When a lower limit and upper limit are same, that integration E dot dl, when you apply upper limit minus lower limit, will always be 0. That 0 into minus qt will be 0. That means the work done will be here is 0. So the work done in a closed loop or closed contour will always be 0. That's what we should write. And that work done, which we know is minus qt line integral, because you are talking about a closed loop integral from b to a e dot dl, this overall will be equal to 0. So what is happening here is this minus q2 into this closed line integral e dot dl is equal to 0. So you will be simply get closed line integral b to a e dot dl is equal to 0. But from this, we are going to get one very important expression if you apply Stokes theorem. If you apply Stokes theorem, what is happening is Stokes theorem is saying that it's a conversion from closed line integral to open surface integral, which is closed line integral a dot dl is always equal to open surface integral of curl of that vector del cross a dot ds. Right? So this closure line integral e dot dl will be absolutely equal to this left hand side part. If you convert that into the right hand side part, what we'll be getting is therefore it's an closure line to open surface, and in place of a what we have is e, that is del cross e dot ds is equal to 0. And this integration will become 0 only when del cross E is equal to 0. So just now in the previous point, I mentioned that when del cross E is equal to 0, that field is said to be conservative field. And now, if the third condition has to be satisfied, the field must be conservative. And in the fourth condition, we have got that. Okay, del cross E is 0. That means E is called conservative field. E is called conservative field. Now, coming to the last point, fifth point is when we try to move, the test charge perpendicular to the electric field, the work done is again 0. Let us now go to the diagram. In this diagram, what we know is, okay, this is the position where you are trying to move the test charge. But here we know very well that the field direction is this. The field direction is this direction. What is the perpendicular direction of field? The perpendicular direction of field is absolutely either this direction or upward direction. Okay, let us try to move the test charge in this direction. That is perpendicular to the field direction. Now I am trying to move the test charge in this direction which I have shown. What is going to happen? If you try to move in this direction, the angle between this is your field direction and this is your DL direction, the angle between them will be absolutely 90 degrees. This is 90 degrees between the electric field E and DL. But in this particular expression, it's very clear that E dot DL, the dot product when both are perpendicular to each other, this will be absolutely 0. This 0 into minus QT will be 0. That means the work done will be absolutely 0. Okay, these are the 5 very important points. Okay, so first one indicating the when the total work done is positive, then the work is done by the external source. Second is when the total work done is negative, then the work is done by the electric field. Third is work done is independent of the path selected. Fourth is work done in a closed contour is 0. Fifth is when you try to move a test charge perpendicular to the electric field, then the work done will be 0. Okay, so these play a very important role in solving the problems. Thank you very much. Okay, hope you liked it. If you like my videos, please subscribe to my channel. Thank you very much.